Today we are going to discuss something about the centroid, or we can call it center of gravity. What is centroid or what is center of gravity? It is an imaginary point where the whole area or whole load is supposed to act. I am particularly using the word supposed to act. When I am talking about the centroid, then we can say the point where the whole area is supposed to act is known as the centroid, and when the point where the whole load is supposed to act is known as center of gravity. There is a difference between the centroid and the center of gravity. When it is two dimensional, that is only area, then that point of center is known as centroid. When we are talking about the three dimension, that is L, B and D or T, with mass or weight, then we call this as the center of gravity. But for all practical purposes, we say that centroid is equal to center of gravity. But basically, we must clearly understand the difference between the centroid and the center of gravity. Now we'll discuss something about the individual sections for finding out the center of gravity of the individual sections. First of all, we talk about the square. The center of the square is a point of center of gravity. Center of the rectangle is a point of center of gravity. The center of the circle will give the point of the center of gravity. Then we are talking about the triangle. It is one third of the height from the base. If height is h, then h by 3 from the base is the height of the center of gravity. But instead of this, if it is a right angle triangle, then the center of gravity lies at a distance of one third of the base and one third of the height. That is b by 3 and h by 3 from the base and as well as from the perpendicular distance. Now, the last one that we are discussing something about the semicircular arc, semicircular, that the CG lies at the center, but in y-axis it is actually at a distance of 4 by 3 into r upon pi. That you must have seen over here, this distance where the CG lies is actually at a distance of 4 by 3 r by pi. This is all about the center of gravity of a single section. Now, suppose this is the area and this is the point where whole area is supposed to act, that is centroid, that is center of gravity. Then how to find out from the center of gravity? Have an x-axis and the y-axis, and this is an origin. Find the coordinates of this x and y, we can call as the point of center of gravity, which is generally denoted by x bar and y bar. X and y are generally called the coordinates, but these coordinates, when written in terms of the x bar and the y bar, it is known as the point of center of gravity. So always the capital X bar and capital Y bar is denoted as the point of center of gravity of any of the area so far. So this is your X bar, this is your Y bar, so this coordinate is X bar, Y bar. Now we'll discuss something about the important theorem, the Varignon's theorem. The Varignon's theorem says that the moment of all the coplanar and the parallel forces at any point is equal to the moment of the resultant at the same point. I will repeat it once again. If we individually take the moments of each and every forces that should be coplanar but the parallel at any distance, at any point or any line, then the resultant of all the forces, when we take the moment of that forces also in the same line or same point, must be equal. We can define this by drawing this figure over here. Suppose there are P1, P2, P3 and P4 are the four forces acting at a distance of A1, A2, A3 and A4 from any of the line AB. Then moment of this force P1 is equal to P into A1, P2 is P2 into A2, P3 is P3 into A3 and P4 is nothing but P4 into A4. These are all the moments taken at the line AB, and the resultant of all the forces is nothing but the algebraic sum of all the forces. This force, if I take these forces as in positive and this as negative, then the resultant force will be P1 minus P2 plus P3 plus P4, we can call this R. Then this R into this distance, which is called as x bar, is equated with this. So we can say P1 x bar 1 minus P2 x bar 2 plus P3 x bar 3 or A3 plus P4 x by 4 must be equal to R into x bar. And from this we can find out the value of x bar as nothing but P1 into A1 minus P2 into A2 plus P3 into A3, so and so forth, upon algebraic sum of all the areas of the forces, or forces we can say. So this is called Vagrinon's theorem, which is most important to find out the forces or the center of gravity of all the forces of any of the objects so far. Now we will consider a single angle section that we have already seen, but when the number of single angle sections more than one rather, I will say, are joined together, that form a single section and we call it a composite section. That is, when two or more than two individual figures are joined together to form a single figure or a one figure, then such figure is known as composite figure or composite section. Here I am talking two individual rectangles. One is this rectangle, another is this rectangle. When both are joined together and it makes a one section, and we can call as an angle section. We can call this as an angle section. Means now this is an composite section. So when we talk about the composite section, how to find out the center of gravity of this composite section? We have to adopt some mathematical tool for that, and for that what we have to do is, it is more convenient and easy to draw a baseline at the last of this end of this figure in x direction as well as in y direction. I don't say that it is essential, but it is more convenient to draw the last line of a figure in x direction as well as the last line of this figure in the y direction, and this will be the origin. So this is, I can call as x, this is we can call as y. Now what we have to do is, we have to divide the whole figure into number of individual figure. We have to divide all this combined or the composite figure into number of individual figure. Here, when we are talking about the unequal angle section, there are two rectangles. One rectangle is like this, another rectangle is like this. Now it is to be divided into two individual figures. So what that I have done, the figure number 1 is starting from here to here. I have taken this as figure number 1 and I have taken this figure number 2, which is already mentioned here. This is figure number 1 and figure number 2. Calculate the value of x bar and y bar of individual figure from this base along the x-axis and along the y-axis of individual from this base only. Now if I, and that is called x bar 1 for figure 1, y bar 1 for figure 1, x bar 2 for figure number 2 and y bar 2 for figure number 2. So we'll have to find out the different areas, different x bar and y bar of individual figure, and we have to put it in a tabular form. Now just see, this total distance is 60 mm and the width is 10 mm, while this another leg having a length of 100 mm and thickness is same as 10 mm. But now what that I am doing, I am considering this as the whole line as a section 2, and right from here to here you can consider say section 1. Then first of all we have to calculate the area of figure number 1, that is, this is nothing but out of this 60 minus the 10, that becomes 50 over here. So this is 50 into 10 is the area of figure number 1. Now we have to find out the x bar 1, that is the center of gravity of this figure from this y-axis. That is the total distance is 10 mm. So CG of this lying at a distance of 10 by 2, that is 5 mm from here. We can call this as x bar 1. When we are talking about the y bar 1, we have to see the y bar 1 from here. Always try to calculate the x bar and y bar from the x-axis and y-axis respectively. So now how much will be the value of this y bar 1? It will starting from here to here, and this distance will be 10 mm. Then this is only 50 mm. The half of this will be the CG of this 50 will be half, that is 25. So this is 25 plus 10, that will give the total 35 mm is the y bar 1 of section 1 or figure number 1. You just see, I have already written x bar 1 is equal to 10 by 2 and y bar 1 is equal to 10 plus half of this over here, that is y bar 1, that is 10 plus 50 by 2, it comes out to be 35. Similarly, now I am talking about this figure. X bar 1 will be total is 100 mm, definitely the center of gravity over here at distance x will be 100 by 2, that is x bar 2, and y bar will be calculated from here, and again it is nothing but is equal to 10 by 2, that is 5. Now you can see here x bar 1 will be, x bar 2 will be equal to 100 by 2, that is 100 by 2 over here, and y bar 2 will be right starting from here, we can just go half of that much, so it comes out to be 10 by 2, that is 5 mm. It is convenient to put all these values in a tabular form for easiness of calculation and to get the quick results. I am drawing in the tabular form. Just see figure number 1, right? And figure number 2. First block comprising of area of A1, then x bar 1, y bar 1. The second one A2, x bar 2 and y bar 2. Once these values of x bar 1 and y bar 1, x bar 2 and y bar 2 along with A1 and A2 are been drawn over here, calculated and put on this table over here, then x bar, the CG of the composite section from this origin, that is x bar and y bar, can be very easily calculated. X bar is taken always from the y axis and y bar is always taken from x axis. Now, x bar is equal to a1 x bar 1 plus a2 x bar 2 upon a1 plus a2. Instead of that P1, P2, P3, here I am taking the area as A1 x bar 1 plus A2 x bar 2 upon A1 plus A2. Substituting the value of this A1 x bar 1, A2 x bar 2 upon A1 plus A2, you will get the value of x bar. That is, you will get the value of x bar from here of the composite section. Similarly, we have to use another mathematical expression for finding out the value of y bar, that is a1 y bar 1 plus a2 y bar 2 upon a1 plus a2. Now you know the area of a1 is equal to 500, a2 will be 1000. Just see, here also written a1 y bar 1 35, that we have already seen over here, plus a2 1000, y bar 2, that is 5 upon a1 plus a2, that will be 15. So here we can say y bar is 15 and x bar is 35. So we can say here it is 35 and here it is 15. Now this is the point. Having coordinates, we can say 35 and 15. And now see what the definition I have given so far. In the beginning, it is an imaginary point where the whole load or whole area is supposed to act. Here now we can see that centroid or the center of gravity is not lying in the section, but it is outside the section. It is an outside the section. So now we can say कि our definition that we have just now shown, just we have seen that it is the point where the whole load or whole area is supposed to act, is found to be true because this CG doesn't lie either in this section nor in this section. So we have to find out this CG, that is, we have to find out the value of this x bar from here, this y bar from here, by using this mathematical expression. X bar is equal to a1 x bar 1 plus a2 x bar 2 upon a1 plus a2, and y bar is equal to a1 y bar 1 plus a2 y bar 2 upon a1 plus a2. This I have just discussed something about the two individual figures which has been joined together and form a single section. We call this as a composite section. Now we can go for again next composite section, which comprising of three individual figure. Just see, three individual figure: rectangle, triangle and a semicircle. First of all, now when this figure is, it is our discretion to decide whether we have to consider figure number 1 is this, figure number 2 is this, or figure number 3 is this. You can select as per your own choice. You can select as per your own choice. Here I have selected this as figure number 1, this as figure number 2, and this as figure number 3. Now, first of all, we have to complete this table, that is just to find out the area of this figure 1, that is A1, then X bar 1 and Y bar 1. So when we talk about this, we have to find out the value of X bar, area of this A2, and X bar from here. X bar 2 will be from here. That is this distance of 20 plus 1/3 of this distance of 12. That is 20 plus 12 by 3, that is 4, that is 24. So we can say X bar 1 will be, if this is 24, X bar 1 will be 12, X bar 2 will be 20 plus 4, that is 24, and X bar 3 will be half of the exactly halfway, that is 12. Now just see, first of all I have calculated the area of 20 cross 30, then X bar 1 from this YY axis. I have taken these as the reference lines. Always consider the outermost line as a baseline vertically as well as horizontally. So X bar 1 lying from here, this total is 20. So it is 20 by 2, that is 10 centimeter. Now when I am talking about this, you know this distance is 1/3 of this distance, which is 12 centimeter. So 1/3 will be 4 centimeter over here. But our CG starts from this end, from this baseline. So it is 20 plus 4, it comes out to be 24. Just see, it comes out to be 24. Second will be 24. Here again, this is 20. CG lies exactly at the center, that is 20 by 2, that is 10. And we can see that the X bar 3 will be 10 centimeter. So we have just calculated the value of X bar 1, X bar 2, X bar 3. First of all, we have calculated the area of this rectangle, area of this triangle, and area of the semicircle. That is A1, A2 and A3. After finding out value of A1, A2 and A3 and finding out the value of X bar 1, X bar 2 and X bar 3, now we will proceed to calculate Y bar 1, Y bar 2, Y bar 3 from this reference line. First of all, I am talking about the figure number 1. Y bar 1 is nothing but, if this is 30, Y bar 1 will lie at a half of this total height. It is 30 by 2, that is 15. Just see, it comes out to be 30 by 2 is 15. Similarly, when I am talking about this triangle, Y bar starts from here. The total height is already 30. So the 1/3 of this, that is 1/3 of the 30, that is 10. You can see it comes out to be 10 mm. And the important is now here. When I am talking about this Y bar 3, Y bar 3 will not be only this much, but it is to be taken right from this origin, this base, and it will be this plus this much. So this is 30, this is 30 plus this much. This much distance is nothing but already taken into consideration, that I have already given in the beginning. It is 4 by 3 into R by pi. It is 4 by 3, 30 plus 4 by 3 into R by pi. And this value we call as the Y bar 3, and this is written over here. Once these values are known, a1, a2, a3, x bar 1, x bar 2, x bar 3, y bar 1, y bar 2, y bar 3, then we can find out the value of x bar and y bar by using the formula a1 x bar 1 plus a2 x bar 2 plus a3 x bar 3 upon a1 plus a2 plus a3, and y bar is equal to a1 y bar 1 plus a2 y bar 2 plus a3 y bar 3 upon a1 plus a2 plus a3, and we can find out the value of x bar as well as y bar. Of course, if you calculate, you can verify this answer whether this is right or wrong, but consider first of all these dimensions and try to calculate. But one thing, important thing is that when we are talking about the y bar, it is from this axis, from this reference line, and we are talking about x bar of individually, it is always starting from this y-axis. Considering this reference line and then call for x bar, y bar, x bar 1, x bar 2, x bar 3, y bar 1, y bar 2, and y bar 3 like this. So similarly, when we talk about the three figures now, this is unequal channel section that is having again three figures. Three rectangle figures are joined together form a channel section C. Again, it is our sweet will to decide which section should be taken as the first section, which should be taken as the second section, and which should be taken as the third section. Here, I have just drawn the dotted line and consider this as the first section. Here again dotted line completing this, so this will be taken as the second section and this will be taken as the third section. Now, first of all, we are supposed to find out the area of this first section. You know this distance is given as 50, this is given as 10. So, area will be 50 into 10. It is 50 into 10 to 500 centimeter square. When I am talking about the figure number 2, now the total distance is already given as 100. Out of this 10 mm and this 20 mm is deducted. So this distance comes out to be 70 mm. Then 70 into this distance will give the total area. This is again is given at 10. So 70 into 10, that is 700 mm, 700 centimeter square will give the area A2. Just see A2, 70 into 10, that is 700 centimeter square. This is third figure. This is given as 80. This is given as 20 now. What is the area of this rectangle? That is third figure. That is the third individual figure I will say now. It will be 80 multiplied by 20. That will give the area of third figure, which will be, you can see it is 80 into 20, that is 1600 centimeter square. After finding out the area of first, second and the third figure, now we will try to find out the value of x bar 1, x bar 2 and x bar 3 of all individual figure from this y-axis. Consider this as the base now. This as the reference line. We have to consider this as the reference line. Now when we are talking about this length, first figure, this is 50. No doubt the CG lies at the center, which is nothing but at 50 by 2, that is 25 mm. Just see, here we can see x bar 50 by 2 is 25 centimeter, not mm, it is centimeter. From here, this distance is given as 10 centimeter. Again, the CG lies at the center. It is 10 by 2, that is 5 centimeter. Now you can see this. You can see over here, This is 10 by 2 is that is 5 centimeter. And now when I'm talking about this one, total is 80. X bar 3 will be 80 by 2, that is 40 centimeter. This comes out to be 40 centimeter. So we have seen how it is 25, how it is 5, and how it is 40. That will give the value of x bar 1, x bar 2 and x bar 3 respectively. Again come back over here and now find out value of y bar 1, y bar 2 and y bar 3 from this reference lines. From this reference line. Always consider this reference lines for finding out the value of individual y bar and this reference line for calculating individual x bar. Now, if I talk about the figure number 1, from here this depth is given as 10 centimeter. Definitely the CG will be half of this much over here. You can see it is there. It is 10 by 2, that is 5 centimeter. Now, if I am talking about the figure number 2, which is 70 centimeter right from here to here, 10 centimeter, 20 centimeter, that is total 30, out of the 100 that becomes 70. So, first of all, let us take this 10 centimeter as such. This is 70. The CG of this lies at a distance of 35 centimeter from here. So, 35 plus 10 must be value of y bar 2. That is just, it has been mentioned here itself. Y bar 2 is nothing but this 10 plus 70 by 2, that is 35 from here, it comes out to be 45. Similarly, when we are talking something in terms of y bar 3, now you can see from here to here, this distance, total distance to right of center, you can see I have drawn the figure over here. This from this to center of this figure over here, that will give the value of y bar 3. How it can be calculated? It is easy. First of all, you know this distance, then you know this distance, and make the half of this distance. I have already mentioned over here. First of all, this 10 centimeter, then this 70 centimeter, and then half of this 20, that is from here. So it comes out to be 90 centimeter. So this way we can find out the value of y bar 1, y bar